Hello, in this video we're going to talk about square matrices that have either a row or column that are equal to each other. So for example, in this very first one, I see the first row is, in this example A, the first row I have is -1, 2, 3, and the second row is -1, 2, 3. They're both the same. Or B, 791, 791, those are both the same columns. And now we move on to this fact. If a square matrix has two equal rows or two equal columns, then the determinant of the matrix is equal to 0. So it has to have, it could have more than two are equal, but if there's at least two rows that are equal, determinant is 0. If there's two equal columns, 0. It doesn't mean that if you add a row equal to a column, 0. That's not true, I guess. But if two rows are equal or two columns are equal, then you get the determinant is 0. So on part A, we have two rows equal to each other. So therefore, the determinant is equal to 0. The second, column 2 and column 3 are equal to each other. Therefore, the determinant is equal to 0. Or, the last one, column 1 and column 3 are equal to each other, and the determinant therefore is 0. I'll do a very quick explanation, but the explanation requires us to know something that's not covered in this video. But for part C, if we add -1 times column 1 to column 3, now if you, for any square matrix, if you take a column, multiply by a number, and add it to another column, it does not change the determinant. Same with rows. If you take a row, multiply by a number, and add it to another row, it does not change the determinant. So if I do, as I said, taking column 1, multiplying by -1, and adding to column 3, I get this determinant. I get the determinant 1, 2, 3, 5, -7, 9. All right, so when I take this first column, multiply by -1, add to the third column. So the first two columns stay the same, and then the third column is all zeros. And the reason for that is that these two columns are equal to each other. So I get zeros over there. But then that's equal to 0 because, as I talked about in a previous video, if you have a column that has all zeros, then the determinant is 0. But we don't want to go through all the steps. We just want to look at these guys here. So that's that's one way to explain it. There's other ways to explain why this is true, but that's one way to explain this statement. Okay, that's all for this video.